So ionic equilibrium, there must be lots of difference, or we can say very minor difference between ionic and chemical equilibrium. Okay, chemical equilibrium, that should be focused on some chemical reaction, their concentration change and their product formation, and the equilibrium, that is the factors affecting equilibrium, as for example temperature, pressure, addition of inert gases. So that should be chemical reaction concerned about the whole over chemical reaction or chemical equilibrium that should be established during reaction. Okay, but physical equilibrium having some different characteristic, that does not always focus on chemical reaction, that does not focus on always product formation, that designate dissociation of electrolytes, their ionic state, their ion formation, buffer capacity, buffer solution, and so many characteristics that can be physically, we can say. Physically means that is there must be no chemical reaction required. Okay. Okay. As for example, ionic equilibrium. Ionic equilibrium, that should be, we have to first consider the term alpha. So first one we consider what are called electrolytes and what are termed as non-electrolytes. Okay. So electrolyte, they always furnish some ions in dissolved state or solvated state. They produce cations and anions. Okay. But non-electrolyte, they are not capable to furnish some ions. As for example, sugar. So most of the cases, non-electrolytes are insoluble in polar solvent, but there are still some exceptions are there. As for example, sugar, glucose. Okay, they are soluble in water or polar protic solvent. Protic solvent means that which give H+. Okay, due to there should be in sugar unit there must be lots of hydroxyl group, and due to this hydroxyl group can be permissible to produce hydrogen bonding in water or alcohol or polar protic medium. Okay. Now we consider electrolyte. Electrolyte means they furnishes always ions in solvated or dissolved state. So they may be weak or strong. So weak means they are furnishes little amount of cations or anions, or we can say they are incapable to produce completely, they are incapable to completely furnishing their ions in dissolved state. Okay. Strong electrolyte always furnishes completely their corresponding cations and anions in dissolved state or solvated state. This is the main difference. Okay. Example of strong electrolyte, that should be HCl, hydrochloric acid, sulfuric acid, nitric acid, so on. And example of weak electrolytes, that should be acetic acid, NH4Cl, so on. Okay, I think NH4Cl not, acetic acid we can say better. Okay. Okay. Alpha means dissociation constant. Okay. Alpha, number of molecules ionized or dissociated by total number of molecules that should be taken. It's very important. That is alpha equal to number of molecules that should be ionized or dissociated by total number of molecules that should be taken. Okay. If alpha equal to 1 means they are strong electrolyte because they are 100% dissociated. Okay, 100% dissociated. But alpha less than 1 for weak electrolyte, as they dissociated less than 100%. Okay, we can say other equation, but it's not so important. This is not so important. You may not memorize it. Okay. Okay. Here, Y is the number of moles of product from 1 mole of reactant that is number of moles of product that should be produced from 1 mole of reactant. D is the theoretical vapor density, okay, and small d is the observed vapor density. So what we conclude, that is capital D that should be theoretically can be given, and small d that should be experimentally observed. Okay, the two defined thing, the two D that should be are not same. Okay, most of the cases our theoretically predicted value and experimentally verified value are not same. Okay, molecular mass equal to 2 into Vd. Okay, okay. There must be other equation is also there, but that is also not so important. That is also not so important. That is MC means calculated molecular weight, that should be calculated. That is, as for example, we can say that is famous example HC triple bond CH. There should be 2 carbon, so 2 into 12 atomic weight of carbon, that should be 12, and hydrogen, that is 2 into 1. As 2 hydrogen is there, and atomic weight of hydrogen, that should be 1.008 mu. We can consider 1 also. So this is called calculated molecular weight. Okay, but M0 that should be observed, that should be experimentally verified. Okay. Okay. So always remember, this is for concept, this is important. Maybe use this is not so important. This is also not so important. Now we come Oswald dilution law, that should be very much important. That should be important. That is K equal to C alpha square 1 minus alpha. K equal to C alpha square 1 minus alpha, where C is the concentration. Okay, alpha is the dissociation constant, K is the equilibrium constant. Okay, where 1 minus alpha, that should be almost equal to 1. 1 minus alpha almost equal to 1. We can consider denominator as 1. So we get ultimately K equal to C alpha square. That is also important. Okay. So always remember, these two equation is very important. Very important. But it is applicable for when 1 minus alpha almost equal to 1. K equal to C alpha square, that should be only applicable when denominator, that is 1 minus alpha, approximately 1. So K equal to C alpha square 1 minus alpha. That is, K is the dissociation constant equal to C alpha square by 1 minus alpha. Okay. We can derive this as per example x, y. Okay, that should be C alpha plus suppose z. Okay, C alpha, that should be 0. Okay, now C into 1 minus alpha, C into 1 minus alpha, we get C alpha. Okay, by this way K equal to C square alpha square by C square, okay, C square alpha square by C square 1 minus alpha okay, mistake, okay, A plus B BC. I think this is not that. Into, that should be 0. C1 minus alpha, C alpha. Okay. Okay. Similarly, plus D, that is 0, C alpha. Okay. So K equal to C square alpha square, that is C1 minus alpha. C cut. That is ultimately we get this value. K equal to C alpha square 1 minus alpha. Okay. Now we consider, if we consider that is alpha equal to this value, alpha square equal to K. So alpha equal to root over K by C, right? C alpha square equal to K. So we can derive that is alpha equal to root over K by C. K is a constant, dissociation constant. C is the molar concentration of solution. So alpha proportional to 1 by root over C. Alpha proportional to 1 by root over C. Okay. Alpha is the degree of dissociation. Okay. Alpha is the degree of dissociation. Alpha is the degree of dissociation. Okay. Now we consider acid. Acid, first one, they turns blue litmus to red. Blue litmus is a one type of paper. It should be given in laboratory. Most of the cases, acid that should be turns blue litmus red. Okay. The litmus is blue, but when it added in acid or it touched with acid, that color that should be changed into red. Okay. Second one, it liberates H2 with metals. When it reacted with metals, it liberates H2. They conduct electricity as they furnish ions, so they can be conduct electricity in aqueous solution and neutralize bases also. Okay, that should be preliminary idea. But we can say acid that should be other definition also there. Okay. That should be acids. They should be furnaces H plus or H3O plus. They can be lone pair acceptor. Okay. They may be having vacant orbital to having lone pair. Okay. And other also concept are also there. Oxide acceptor and so on. Okay. Okay. Bases are turns red litmus blue. When red litmus that should be introduced in basic solution or bases that should be added, on that case the red litmus turns into blue. By this color change, we can conclude the substance is base. That should be soapy to touch. As for example, when we produce any OH solution, always remember by hand, the hand there must be soapiness can be there. Okay. Conduct electricity in aqueous and neutralize acid. As it neutral acid always neutralize acid, and base always neutralize acid, and acid always neutralize base. Okay. And always conduct electricity in aqueous solution, because basic solution also furnishes ions. Okay. And also you can say photogenic means photon donor. Photogenic means photon donor. That as for example acid is a photogenic. And photophilic, that should be photon acceptor. Photon, that is H plus, that should be acceptor as for example base. Okay. Acidic strength, that is HCl4 is the highest. HCl4 is the highest, then HI, then HBr, HI, HBr, then H2SO4, then HCl, then HNO3. Okay. If we consider base, first one, they should be furnaces OH minus. Okay. Second one, they should be hydrogen ion acceptor. Okay. Third one, lone pair donor. This is the basic concept. That should be Arrhenius concept. That should be Bonston-Lowry concept. And that should be Lewis base theory. Okay. Okay. Next one. Now consider Kw. Kw is nothing but multiplication of concentration of H3O plus and concentration of OH minus, and that should be 1 into 10 to the power minus 14 mole square liter into the power minus 2. For acidic, there should be always concentration of H3O plus that should be greater than concentration of OH minus. Neutral, their concentration that should be same, and for basic, concentration of H3O plus that should be less than concentration of OH minus. In pH scale, that is pH means minus log of concentration of H plus. Concentration of H plus means that is 10, if we convert, that is minus log to this side, we get 10, that is minus 10 to the power pH. Okay, that is Ka into Kd, that should be equal to Kw. Okay, now we consider that is POH equal to minus log of concentration of OH minus. Minus log of concentration of OH minus. Okay. Now consider Kw. That is a concentration of H3O plus into concentration of OH minus, that is 1 into 10 to the power minus 14 at 298 Kelvin. Okay. Now consider if pH equal to minus log of H plus. So when log goes to this side, we get ultimately 10 to the power minus pH equal to concentration of H plus. Okay. As we know, when ln, that should be ln goes to this side, we get E, and log goes to this side, we get 10, base 10. As log is a base 10. Okay, that's why log is a base 10. That's why we get it. Okay, now we consider pKw equal to pH plus pOH equal to 14. Now we consider for alpha, for K alpha, that is when acid, that should be dissociated, that is HA, that should be dissociated into H plus A minus. There should be equilibrium. Then we can say concentration of H plus into concentration of A minus by concentration of HA. That is concentration of products means H plus and A minus by concentration of HA, that should be K alpha. Okay. K alpha for dissociation constant for acid. Okay. Equal to C alpha square 1 minus alpha, which are previously we can say by this way. Okay. Now we consider for base. For base, as we know, that is BOH. That should be, there must be equilibrium B plus and there should be OH minus, right? So first one, numerator, the concentration of product by concentration of reactant, right? So Kb is a dissociation constant of base, that is equal to concentration of B plus by concentration of B plus into concentration of OH minus by concentration of BOH. Similarly, we can get it, that is C alpha square 1 minus alpha. Okay. 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 Get it, this product formation, this we get this. Okay. Now consider for H3PO4, that is phosphoric acid. There should be first dissociation, it must be produce H plus plus H2PO4 minus. This constant is Ka1. Okay. Next one, H2PO4 minus, that should be dissociated into H plus again and plus HPO4 2 minus. Okay. Ka2. Okay. That constant. Last one, HPO4 2 minus, it must be furnishes again H plus plus PO4 3 minus. Up to this, after PO4 3 minus, there is no acidic proton, so no possibility to lost proton. Okay, so that is Ka3. Okay, so overall dissociation constant, that should be K equal to K1 into K2 equal to K3, so on. Their product, that should be the, so in that case, we can say that is K overall, their dissociation constant Ka1 into Ka2 into Ka3. Okay, they are product only. Okay. Now we consider pH of H2PO4, that is nothing but pK1. That is the first reaction, pK1 by pK2. That is pK1 and pK2. Okay. So pH of H2PO4 minus is the average of pKa1 plus pKa2 plus 2. pKa1 plus pK2 by 2. Okay. Okay. Next one, pH of HPO4 minus. That should be average of pK2 and pK3. Ultimately, the last one, pH of H2CO3, that is pH equal to pK1 plus pK2 by 2. Okay, so that's it. Now, from the group HI, HBr, HCl, HF, down a group, top to bottom, acidity, that should be acidity increased. Why? Because in that case, hydrogen is this, iodine is this. Ineffective overlap, HBr, hydrogen is this, HBr smaller, slightly smaller than iodine. So there must be moderate effective overlap. Okay. Then HBr, that is hydrogen and chlorine. And last one, hydrogen and chlorine. So observe it, from HI to HF, the size of the iodine, that should be highest, then Br, then Cl, then chlorine. So we consider, okay, oh sorry, there, okay, I think Br, Cl, F, that should be this, top to bottom. Okay, acidity increases. Okay, so from I, Br, Cl, F, size decreases. So overlap with hydrogen also decreases, as hydrogen is a smaller in size. So hydrogen produce more effective overlap with fluorine, then chlorine, then bromine, and last one, iodine. So as overlap, that should be ineffective for HI. So HI, that should be more having tendency to dissociate it and giving H plus. And similarly, then after iodide, Br is most larger after iodine. So there should be, due to ineffective overlap or more larger size of bromine, so H plus removal is easy. So by this way, from HF, HCl, HBr and HI, from top to bottom, acidity increases in terms of overlap idea. Okay. Now we consider that is down group, acidity increases due to overlap. From top to bottom, overlap integral or overlap region, that should be decreases. Okay. So due to ineffective overlapping, hydrogen removal more easy. Next, from left to right, their electronegativity, that is chi, that should be increases. So acidity obviously increases. From carbon to nitrogen, nitrogen to oxygen, oxygen to fluorine, electronegativity increases. So acidity, that should be increases. Okay. Now we consider some salt. As per exam, first one, normal salt, that should be obtained by complete neutralization. As for example, NaOH plus HCl, it should reproduce complete neutralization NaCl plus H2O. Okay, there should be complete neutralization. That is called normal salt. Okay. Acidic salt obtained by incomplete neutralization by polybasic salt. As for example, NaHCO3 and Na2HPO4. That is incomplete neutralization of polybasic acid. Polybasic acid. That is NaHCO3 and Na2HPO4. As you know, that is carbonic acid. They are all hydrogen are not replaced. Partially, one hydrogen that should be replaced by base. So they are termed as acidic salts. Okay. Similarly, H2PO4, there must be 2 hydrogens. H3PO4, there must be 3 hydrogens. There must be partially satisfied by NaOH or other base. That should reproduce Na2HPO4. All hydrogens are not lost from H3PO4. Okay, so that's why it termed as acidic salts. Next one, basic salt obtained by incomplete neutralization of polyacidic base. As for example, BiOH whole twice Cl, MgOH whole twice. See, there both of the cases there must be OH is still there. Means OH are not neutralized completely by acid. So that's why we can term as they are basic salt. These type of salts are called basic salts. Now we last and least the slide that should be double salt, that is combination of 2 simple salt. As for example, ApSO4, NH4 whole twice SO4 dot 6H2. That is called alam. Means simple salt that should be explained previously, right? Simple salt or normal salt that should be simple. Same. Okay. So that's why double salt is nothing but that is a combination of simple salts. Okay. Example, ApSO4, NH4 whole twice SO4 dot 6H2O. And alam also. Okay. Complex salt, that should be combination of simple salt as well as some simple salts or molecular compounds. Property that should be defined, that should be changed. Okay, that is termed as complex salt. Combination of simple salt or molecular compounds, but properties that should be changed. Okay. Last one, that is mixed salt. That should be furnishes more than 1 cations or anions, more than 1. Okay, normally NaCl that should be furnishes 1 cation and 1 anion, but they should be produce more than 1 cations and more than 1 anion. That is termed as mixed salts. As for example, CaOCl, that should be produce Ca2 plus, Cl minus and OCl minus. Okay. Similarly, these are the example. Okay. Okay. So they are termed as mixed salt. Now one salt of that is weak acid and strong base. As for example of that is weak acid and strong base. That is acetic acid is a weak acid. And strong base, that is sodium hydroxide. We get the, that is CaCCOONA due to combination of acetic acid and NaOH. NaOH, that should be a strong base, sodium hydroxide, and acetic acid is a weak acid. Okay, so KH hydrolysis constant Kw by Ka, that should be H degree of hydrolysis, that should be root over Kw by Kn/C. Root over Kw by Ka/C. pH of the solution half of pKw plus half of pKa plus half of log of C. Okay. Now we consider strong acid and weak base, that is combination of strong acid and weak base, that should be NH4Cl. NH4OH, that should be weak base, ammonium hydroxide, and react with HCl, that is hydrochloric acid, that should be strong acid. We get NH4Cl ultimately. So KH hydrolysis, that should be Kw by Kb, and that is H hydrolysis of degree of hydrolysis, that should be root over Kw by Kb into C. Root over Kw by Kb into C. And pH of the solution half pKw minus half pKb minus half of log of C. Okay. Then salt of weak acid, weak base, that is should be CaCCOONH4, that is combination of acetic acid and ammonium hydroxide. Ammonium hydroxide is a weak base, and acetic acid, that should be a weak acid. Due to their combination, this type of salt can be produced. Okay, this is an example, but there are lots of type examples also available. Okay, KH hydrolysis constant Kw by Ka into Kb. Kw by Ka into Kb. Okay. H degree of hydrolysis, that should be root over Kw by Ka into Kb. Root over Kw by Ka into Kb. pH of the solution half pKw plus half pKa minus half pKb. Okay. Last one, strong acid and strong base. That should be example NaCl, that is NaOH sodium hydroxide plus combination of hydrochloric acid HCl. Both are strong acid and strong base. They are completely dissociate into cations and anions. That is the example NaCl. And KH does not undergo hydrolysis. There is H, none. Degree of hydrolysis, pH of the soil, that is also none. Okay. Actually, there must be acidity and basicity, all are neutralized. There must be no acidity, no basicity at all. As we take regularly table salt, we can know there must be no test for acid and no test for basic. That is harmless compound is NaCl or table salt. So because due to this, that is there must be completely neutralized form of acid and bases are there, and completely new compound is produced NaCl. Okay.